Hello, and welcome to this lesson on finding missing parts of similar figures. So this is a continuation of the previous lesson, where we were learning all about similar figures. We learned that similar figures are proportional. Well, we're going to use that same idea to help us now use properties of similar figures to find unknown sides and angles. Did you know you can find the height of any object outside as long as the sun is shining? All you need is a measuring tape and a friend. And if you see example 2a in this lesson, we're actually going to do a very similar problem there. This works for buildings, flagpoles, trees, or anything as long as you can measure how long its shadow is. Vocabulary: there is none, still. So, finding missing pieces of similar figures. Use properties of similar figures to find the missing angles. So right now we have three angles without measures. We don't know how big this one is, and that one. So we want to find those three angles. Things I can do right off the bat. I know that this is 52 because the two shapes are similar, which means their angles are exactly the same. Oh, I forgot to read the question. What is the measure of angle x? Really, this is the one I need to find, but this is helpful information as well. I need to find this. And I also know that these two angles here will be the same. They're corresponding. So the last bit of math I need to do to find this is the knowledge that all the angles of a triangle add up to 180. So 52 plus 90 plus something equals 180. You could do guess and check. You can do some math like I'm going to do. 90 plus 52 is 142. And if I take 180 and I minus 142, I get the missing piece, which is 38. So both of those are 38 degrees. And that was an ugly, both of those are ugly. Man, let's try again. There we go. Okay, so they're both 38 degrees because they're the same. That was fairly straightforward. It's just finding missing pieces. Triangles add up to 180 degrees. Rectangles add up to 360. That's pretty much all you need for angles. Sides. Find missing sides. Let's see. Find ST. I'm actually reading the question this time. ST and DF. So we need to find both of those pieces. Now, the way that we learned in the previous lesson that similar figures, their sides are in proportion. Well, we can use a proportion to compare and to find missing side lengths. Check this out. 12 over x. I'm going to call him x. So 12 over x equals 20 over 10. And we can solve this proportion. We can cross multiply and solve for x and find it. So cross multiply, that gives me 120. That gives me 20x. When I divide by 20 on both sides, x equals 6. And if this cross multiplying is unfamiliar to you, I encourage you to go back to, there was a lesson way back, it was actually the very first unit we did, towards the end of the unit, on solving proportions using cross multiplication. I encourage you to check that out. That had a lot more algebra stuff to it, but there was also some just general proportion stuff as well. All right, so I found one missing side. Now we just have to do that process again, but I'm going to have to use different proportions because I can't use those side lengths. I have to use this side in one of my proportions. So I'm just going to go the other way. I could have also done across the top. I could have done like these two here and these two here. There's nothing wrong with it, but I like the up and down. So that's what I'm going to do. So I'm going to set up the proportion 9 over 6, that's here, 9 over 6 equals y over 10. He is now side y. And I cross multiply. There is 90, there is 6y. To solve that equation, we're going to divide by 6 on both sides, and y equals, I'm not sure, 90 divided by 6, is it 15? No. Yeah, it was. Equals 15. And there we have it. And really, in these first two problems, just like the previous lesson, we've learned everything we need to learn for this whole lesson. Now it's the rest of the problems just going to be practice. We know that they have the same angle measures, so you can kind of use that fact to find missing angle measures. And we know that sides, or the shapes, if they're similar, they are in proportion. So you can use a proportion to find a missing side length. That's it. Now we just do a lot more of that. Letter C. The two shapes are similar. Find and label all missing angles. So some of these are very easy right off the bat. Like, I mean, this is the most pointy angle here, and this is the most pointy angle here. So these two are corresponding. So this guy's 40, just like he's 40. And then, I mean, kind of working our way around, we can see that letter C there is 133, and then A would be 52. So now these two, we have almost all the same angles, but we are missing B and X. So in order to find that, we have a little extension on that thing of all triangles add up to 180. All quadrilaterals, four-sided figures, their angles add up to 360. So if I took 360 and I'm going to subtract 40 and subtract 133 and subtract 52, basically they all add up to 360. If I take away this angle, and this angle, all I'll be left with is that angle. That is 135. 135. All the angles of a quadrilateral add up to 360. And we know that because a quadrilateral is just two triangles. And this triangle adds up to 180, and that triangle adds up to 180. Together, that makes 360 degrees. All right. We've done a couple here together. Now it's one for you to try. So letter D says PQR and triangle XYZ are similar. Similar. Find all missing sides of both triangles. So you need to find the length of this side and this side and this side. Okay, go ahead and pause the video. You can do that right now. When you're ready to continue, hit play, and we'll go through it together. All right, so there is some problems, and you might have stumbled at first. I mean, we cannot set up this proportion because I only know 2 out of those 4 sides. I can't do that proportion yet. I can do and will do this proportion because now I'm only missing one side. So I'm going to call him X. Or since I already have an X, how about we call him A? That way we're not confusing with X up here. So I can do this proportion and find this side. So let's do that. 8 over, oh man, I had a feeling that was going to happen. Let's go over here. 8 over 6 equals 36 over A. 8 over 6 equals 36 over A. That's my ratio. Cross multiply, we've got 8A and 6 times by 36. I'm pretty sure that's 216. 6 times by 36, 216. And then we're going to divide both sides by 8 to solve this equation. And we get A equals 27. So we now have one of our sides. A equals 27. Now there's still a problem here because I can't like to find this side. Let's call him B and C. Okay. To find B or C, like I can't do this proportion because I don't know what B or C is. This proportion is not going to work out. Like if I set it up, it'd be C over 6 equals B over 27, and we can't solve that equation. We can't, if we cross multiply, we have two unknown things. So that's not going to work. Likewise, we still can't do this proportion. So, did you find the right thing to do? How do you find the missing side of a right triangle? Did you use Pythagorean theorem? You should have. If you didn't, maybe you want to pause the video, and now that you know what to do, you can do it. A squared plus B squared equals C squared. I'm going to just do this one here. So we've got, 8 squared plus 6 squared equals C squared, and 8 squared plus 6 squared equals 100. And then when you square root both sides to get the C by itself, you're going to get 10. Square root of 100 is 10. So this is 10. Now, decision time. You could do Pythagorean theorem again. Or you could do a proportion like that, because now there's only one missing piece. Or you could do, some other setup of proportion, do like these two and those two. That's up to you. Or would have been if you did the problem on your own. We will still get the same answer no matter what method we do, if we do Pythagorean theorem or the proportion. So I'm going to do Pythagorean theorem. It's been a while since we've done that, and I like it. So I'm going to do Pythagorean theorem of this triangle. I need space though. So A squared plus B squared equals C squared. It's the formula. I was getting a little wonky in my brain because I have it labeled A and this is a B, even though that's the hypotenuse. It's okay. We'll make it work. So then the two short sides, the 27 and 36, go in here. So 27 squared plus 36 squared equals, and in for our C, we're going to put the letter B, side B. Okay, 27 squared plus 36 squared is 2025. And then we square root both sides to get the B by itself. Square root the answer, 2025, giving us 45. And there we have it. We found each of our missing sides. This was side 10, this was 45, this was 27, and to be good role model, let's throw in our units, inches. Okay. Applications. It's really more of just kind of the same thing, but this is the one that relates to that the did you know at the beginning. Miguel is trying to find the height of the flagpole in front of his school. The sun shines on Miguel and the flagpole at the same angle, casting shadows and making similar triangles, which is true. This actually does work. Miguel listed the measurements he knows in the sketch below. how tall is a flagpole? So Miguel measured maybe either himself or a friend and got 5 foot, and then measured the shadow, being 3 foot. He could then measure the shadow of the flagpole. You just put a tape measure on the ground or something, and you got 17 foot. Now, using these measurements, he wants to know how tall is a flagpole. Okay, well, that's not too bad anymore. Now that we know the process, now that we know that they're similar and we can use a proportion, we're just going to go boom and boom. X over 17 equals 5 over 3, and we cross multiply. So that gives us 3x equals 17 times 5. 85, divide by 3, divide by 3, x equals 28.3 repeated feet. So that flagpole is 28.3 repeated feet tall. Fairly straightforward now. The process was pretty easy once we had the knowledge now of what to do. In a scale drawing of a sailboat, the mast is 18 inches tall. So the mast would be this thing here, the thing that holds up the sail. The mast is 18 inches tall, and the boat is 15 inches long. The real boat's length is 42 feet long. If a triangular sail stretches the length of the boat and the height of the mast, what is the area of the sail for the real boat? And my little hint is that scale drawings and models make similar figures. So the scale drawing of the real boat would be similar to the real boat. Mathematically similar. So you can use a proportion to find missing sides and stuff. Okay, so I'm going to make another little boat over here. There you go. So now I have, like, we'll call this one the drawing of the boat. So it's mast. I need to make it bigger. I need to label stuff. So like that, and sure. All right. And I'll change color because I've got too much blue on the screen. So the mast is 18 inches tall. So this part is 18. And the boat is 15 inches long. This part here, it's 15 long. Okay, so this is 15. The real boat's length is 42 feet long. 42 feet long. And we want to know what is the area of this sail. Well, background knowledge. Area of a triangle. Area equals 1/2 base times height. I have the base of this triangle. This triangle's base, because it's the length of the boat, is 42 feet. I am missing the height. I don't know that. That's kind of the thing. If I could figure out the height of the real boat's masts, we could just throw it right in there and we'd be done. Well, we can do that. 18 over 15, ratio, proportion, x over 42. 18 over 15, x over 42. I'm gonna use this proportion to figure out what is the height of the mast. So let's see, we've got cross multiply. This side is 15x. That side is whatever 18 times by 42 is 756. And then we're going to divide by 15 on both sides when we solve this equation. And x equals 50.4 feet is our unit. And I'm looking at, and that makes sense. The mast is taller than the boat is wide. The mast of 50.4 is taller than the boat is wide. So it's 50.4 feet. And now that I know the height of this, the height of the triangle, I can throw that in for the height of the triangle. 50.4. And our area is now just a couple button clicks away. 1/2 times the base times the height. 1058.4 feet squared is our final answer. So take a second and relook through the problem if you need to. So I drew another boat so that I could label my parts. We figured out that in order to find the area of the sail, you need the base and the height. We were given the base in our description, but we did not know the height. So that was the first part of the math we had to do. We had to find the height of the sail. And since these boats are similar, we did a proportion. We found the height was 50.4. And now that we know the base and the height of the sail, we can plug them into the area formula for a triangle. 1/2 base times height, put in the base, put in the newly found height, and there is our area. Letter C. Jose and Alicia are trying to solve the problem below together, but disagree on how to solve it correctly. Your job is going to be to determine who has the correct method, and then explain why the person with the wrong method is wrong. So, here's what Jose believes. They're trying to find side x. Jose believes x is 10 because it fits the pattern he sees in the picture. It's like AB is 5 and BC is 5. AE is 4, ED is 4. Since CD is 10, BE would also be 10. Okay, so it fits the pattern. That's what Jose believes. Alicia believes x equals 5. It says she had to set up the ratio AB over AC, which was 5 to 10, and found a scale factor of 1/2. So half of 10 is 5. So who do you think is right? Do you believe it to be Alicia or Jose, or maybe neither of them? So take a minute, pause the video. I'm gonna scroll back between Jose and Alicia here one more time in case you need to see it, and then figure out who you think is right and try to explain why the person you believe is wrong. Okay. Okay, so first off, there's an easy way to figure out why Jose is wrong. Jose is definitely wrong. Okay. If you would take these two triangles, they're kind of wrapped up in the same picture. If you would disentangle them, here's the one, here's the other. Little guy is 5, 4, and x, right? So that's ABE, 5x4. Big guy is 10, 8, and 10, right? 5 and 5, that's a length of 10. That's 10, that's 8. Well, we can see right now that no, this would not be 10. That wouldn't make sense. If these are similar figures, and we know that these two sides are the same, they are, look at them, 10, 10, then technically these two sides should be the same thing too. This would also be 5. So Jose is very wrong. I like that he was looking for a pattern, but he didn't kind of separate the two triangles out and see how long the sides actually are. Okay? Alicia's method does work. The scale factor here between these two triangles is 1/2. If I go back here, let me copy and paste this one. Copy, paste. All right. So Alicia found the scale factor of 1/2. And we can see that by looking at this picture that this 5 is half of 10. 8 is, I'm sorry, other way. 4 is half of 8. This triangle here is half of this triangle here. Okay, so scale factor of 1/2 does work. And then by taking 10, multiplying by 1/2, you would get 5. Alicia could have also done this using a proportion. Once you separate these triangles, you could just use a proportion and say like x over 4, 10 over 8, and cross multiply, and you would again find that x equals 5. Okay, so Alicia is correct, Jose was wrong for multiple reasons, but these are the reasons that we came up with. All right. Summary. Describe the relationship, not the relationship between dilations, similarity, and proportions. Now, similarity, we mean like similar figures. So what's kind of connected between dilations, similar figures, and proportions? Maybe you can come up with a sentence that uses all three of those words in it. So you could say something like, similar figures are the result of a dilation, and similar figures, lengths, side lengths, are proportional. Dilations make figures that are proportional, and they are also similar. Proportions can be used to find the side lengths of similar figures. There's lots of different things you can say. I've listed off a couple, and feel free to pause the video and go back and write a couple of them down if you want to. But those three things. Dilations make similar figures, and you can use proportions to show that they're similar, and you can use proportions to find missing sides. Like they all kind of go together. All right. Thank you so much for watching this lesson on finding missing pieces of similar figures. Until next time, toodles.